Yes, we are on our part 2 video. When we left our video, guys, we were at the stage where we are having same denominator. You add the numerator, so we have root 2 there. Then cos plus sine x, you add the numerators, right? Remember that cos plus sine x was given as k, so your answer will be k root 2, right? Then we can rationalize this. So root 2 times k, this will be root 2k here, divided by root 2 times root 2, that will be 2. Yes, this is your solution in this case. So that's how you can find express this in terms of k. Express cos x minus 45 in terms of k. That was 4 marks, right? Let's go to 5.4 then. Then at 5.4, we are required to prove the identity. Cos 2 theta plus 1 divided by sine 2 theta plus tan theta, which is equals to 1 divided by sine theta cos theta. So how many marks was that? That was 5 marks, guys. That was a beautiful 5 marks that we were supposed to get it. You're supposed to get it, guys, that one. So even if you didn't do well, there's still a chance in prelim you can improve, right? So let's put that into practice. Let's prove. But the easiest way is to start with a side that is most information in. So in this case, we could see that the left hand side is appropriate to work with it. Let's put that into practice. As we have stated, we will start with the left hand side. So you can choose a double angle that is appropriate to work with. So let's change sine first. Sine 2 theta. That will be sine 2 theta and cos theta. What about cos 2 theta? We can change cos 2 theta to let's change it to a double angle of sine in terms of sine. So we are going to have 1 minus sine squared theta plus 1. Some can use that the 2 cos squared theta. We can use also that one because we also have sine here and cos, right? So we can change tan theta. Since it's a quotient identity, it will be sine all over cos theta. So from there, we can find an LCD. LCD will multiply these two denominators. So it's going to be 2 sine cos times cos. That will be 2 sine theta cos squared theta, right? So from there, we can cross multiply. So when you cross multiply, cos times 1, that will be cos theta. Cos theta times sine squared theta plus 1, that will result to 2 sine squared theta and cos theta. Yes, if you multiply this, right, you're going to get 2 sine squared theta cos theta plus cos theta. Yes, you can just multiply it out. Then let's multiply this. 2 sine cos times sine, that will be plus 2 sine squared theta cos theta as well, right? So from here we can find the like terms. We could see that this and this, they are our like terms, so they will cancel each other. Negative 2 sine squared cos theta and this. Then we are left with what? Cos theta plus cos theta. It's 2 cos theta divided by sine theta multiplied by cos squared theta. Remember, this is 2. So what is nice is that cos theta and cos theta here, 2 and 2 will go. We'll be left with 1 cos here at the denominator. So we have sine theta multiplied by cos theta. At the numerator, we're left with 1. Then the left hand side, we could see, is equals to the right hand side, which is this side, right? So that's how you can deal with 5.4 when proving. You can also use other double angle to prove. Any appropriate method can work here. Then lastly, we will look at 5.5. determine the general solution of the equation. How many marks was that? That was 6 marks, guys. Okay, so we are given 4 sine squared theta, which is equals to cos 90 minus 2 theta. 90 minus 2 theta, guys, remember, cos 90 minus 2 theta, it's a cofunction, so it will change, guys. It will change. Remember that we were supposed to determine the general solution of the equation. 4 sine squared is equals to cos 90 minus 2 theta. Cos 90 minus 2 theta, it's a first quadrant, so it will change to sine 2 theta, which is a double angle. So we have 4 sine squared theta there. Then let's change sine 2 theta. This will be 2 sine theta and cos theta, the double angle of sine 2 theta. So we have 4 sine squared theta there. Then we could take 2 sine theta and cos theta to the left hand side. 2 sine theta and cos theta equated to 0. So from here we can find the highest common factor. The highest common factor, we could say that it's 2 here. It's 2 sine theta. Then I'm left with what here? 2 sine theta. Because 2 sine theta times 2 sine theta will give me 4 sine squared theta. To get here, I need 1. Then I will then equate everything to 0. So I'm having 2 sine theta equated to 0, or 2 sine theta equated to 1. Then from there I can divide everything by 2 here. Can also divide everything by, oh, I'm making a mistake here. It was supposed to be cos 2 sine theta minus cos. Okay, so meaning that we are going to have 2 sine x sine theta, sorry for that, which will be, if we take cos to the other side, it becomes cos theta, right? So we can divide everything by cos so that we make it a quotient identity, cos theta. Then cos and cos will give you 1. Then sine all over cos will give you tan 2, it will give you 2 tan theta. Then for us to make theta the subject, we're going to say 2, we're going to say tan theta, which will be equal to half, right? Okay, but let me deal with this first. So remember, we will have sine 0 here, sine theta, which is equals to 0. So if you find a reference angle of sine theta there, the reference angle of sine 0, second function of 0 will give us 0. So it will be 0 plus k times 360. Sorry for that, which is the k. K is an element of integers. So we can also think of other alternative. This is where sine is positive. So when you say 180 minus the reference angle 0, we're still gonna left with 180 plus k times 360, right? So we'll have 2 solutions here. Similarly, guys, you can also do the same thing here. Let me leave this for you to do it. So we're going to say tan arc there. What is tan arc of 0? Then you will get the answer. So in that answer, you will use you will say 180, and where k is the element of integers, and you also check where sine is positive. So in that manner, you will have gotten all that 6 marks. So that's how, guys, we can work out question 5, mathematics paper 2. Hope you find this video useful, and do not forget to subscribe. See you on the other questions as I am progressing on doing all the questions. Yes, so I will upload all of them. So yeah, I wish you well, guys. See you in the next video.